Hello and welcome to another one of D's ADD videos. Today we're going to look at part 2 of conversions examples, and basically we're going to look at a problem in which we have kilometers per minute and we want miles per hour. So what do? Well, as always, you start out with what you were given. I don't want to highlight all that. And then you multiply by your conversion factor, that second fraction, to get what you want. And here we're given 65 kilometers per minute. So we multiply that by the first conversion factor. And in the first conversion factor, we're going from kilometers per minute to miles per minute. Okay. We cancel out the kilometers. Here you can see there's Chem on the bottom, Chem on the top. They'll cancel. And be left with the miles and then the minute that was there. So then we multiply by another conversion factor to go to hours. So we know that there's 60 minutes in 1 hour. When you multiply through, you get that. And let's say this was a calculation. All of these on this handout are examples of data problems. So I'm using sig figs. But unless you're asked to do so, or it's an actual experiment, then you really need to worry about sig figs and these conversion factors. So here you round it up to 2 sig figs because 65 is 2 sig figs. All right. So here, how many millimeters? And 12 nanometers. So what is the purpose of this problem? Well, most people don't know how many nanometers there are in 1 millimeter. So what you're going to need to go is go to the standard SI unit, the base unit, in this case meters, then convert to millimeters. Okay? So here, that's exactly what I did. I started out with the nanometer, and then I used the first conversion factor to get it into the meters. I know that, again, if I let 1 be the larger measure, 1 meter is larger than 1 nanometer, so therefore I put a 1 in front of the meter, and then I avoid the -9 exponent always if I do that. All right, but then I want to go to millimeters. What do I do there? Well, I multiply by the next conversion factor, which will get me there, and notice that the meters will cancel top and bottom, and we'll be left with millimeters. All right. So here I'm just overemphasizing meters greater than millimeters and nanometers, so meter gets the 1 in both of those scenarios. All right. Okay, so let's look at something else here. Here we have millimeters per millisecond, and we want to go into micrometers per second. Okay, so again, same concept as always. The second fraction you might have to do more than once, but it's always what you're given times a conversion factor, which is obtained from that table in the back. Okay. Here we have millimeters per second, and we want millimeters per millisecond, and we want meters per micrometers per second. Getting tired, sorry. So at this point, what do? Well, first, let's take it one step at a time. Let's deal with the length. If I want to go from millimeters to micrometers, not many people know that there's 1,000 micrometers in 1 millimeter. But so what I'll do is I'll convert it first to meters by using this conversion factor, and I put 1 on the larger unit, in this case the meter, and therefore I have no negative exponent there. Now I'm in meters, which is the base unit for distance in the metric system, and then I can convert that into micrometers. And hopefully you can see that this is a little typo right there, so let's go ahead and fix that. That should be a meter right there, and whenever we compare meter and micrometer, we end up with meter being larger, so we put a 1 in front of the meter, and then there's no negative exponent for the micrometers. And that second conversion now has brought us into the land of micrometers in the numerator, where that's what we want. So now the goal is to go from milliseconds to seconds in the denominator. So you should remember that anytime you see the lowercase m in front as a coefficient, what does that mean for you to do? Well, it means we have 1,000 of those, whatever unit that is in the base unit. So we multiply and then convert. And now you can see millimeter cancels, meter cancels, left with micrometer. Millisecond cancels, left with seconds. You multiply, use your sig figs to get that, okay? So again, I'm overemphasizing, put 1 for the larger unit of measure, and if you do that, then you won't have to deal with negative exponents. Once you get more familiar with the conversions, sure, deal with negative exponents, make sure it makes sense in your head. Don't just brute force memorize this stuff and learn it out of fear of getting a bad grade. Just try to understand it. It's a lot better that way, okay? So here we have something in which we are going from centimeters squared to meters squared. The trick here is this little portion of it right there. Whenever you have a conversion of a square meter or square centimeter to a square meter, you got to also square the conversion factor. And then normally if it was just centimeters to meters, it would be 101. But because it's centimeters squared, we got to account for both dimensions, and we get 100 squared. All right. So those are some examples. I'll do a couple more, not much more though. I think that should pretty much cover our bases. Let's look at this one here. Here we have 35 feet or kilometers per hour, and we want feet per second. So do your little table. So I know that I put kilometers down here, and then I put feet up there, or miles. Let's do miles. I believe there's 1.6 kilometers per mile. Let's double check that. Better to err on the side of caution if to err at all. It's a nerdy way of saying better safe than sorry. Yeah, 1.6 kilometers. Alright, so we put a 1.6 right there and 1 mile. So now we've got the miles, and then we know that there's, in 1 mile, 5,280 feet. And we know that in 1 hour we have 3,600 seconds. So bust out your handy dandy calculator. Question is, where did I put mine? I guess I'll use my trusted phone. Give me 1 second. Okay, let's do 5,280 divided by 3,600. Then take that answer and divide it by 1.6, and then times 35. Okay, if you remember that you can get any, or you can multiply and divide in any order, left to right. So we have 32.083 to 3. We'll just go with 32 feet per second. Okay, let's look at this one here, just overemphasizing things here. 2.5 millimeters squared. If you don't know that there is 10 millimeters in 1 centimeter, then you would need to go to meters first and then back to centimeters. But that's a lot of work. After you come to understand this stuff a little bit better, you should be able to understand what I'm doing here. I know that if I put a 1 on the larger measure, and I put a 10 there, but because it's squared, I put a square there. That becomes 100. Then 2.5 divided by 100. I'll just be lazy and do 2.5 times 10 to the negative 2 centimeters squared. Okay, so that's basically a bunch of conversions. The only way to get good at these is to do 50 of them, 100 of them, however many it takes for you to get it to where you can do it in your sleep. Okay. Don't try to do all 50 at one time. I recommend brief bursts of 10, 15, 20 at a time. Practice, practice, practice. Thank you, and have a nice day.